on 54 of Neetcode 150, binary tree right side view. Alright, so we are getting a root of a binary tree, and we have to only return the values that can be seen from an observer that stands from the right of that binary tree. Okay, so for example, if I stand to the right of this binary tree, and also let's say that I am Pac-Man, so I'm living in 2D world. So in this 2D world, if there is the node 3, right, and I'm to the right of node 3, I can technically not see the node 2, right? It's like a wall that blocks node 2, okay? And this is true for every levels, right? So for example, here, if I stand to the right of this entire tree on the level 1, there is only one node, so I can only see one, but on the level 2, there are 2 nodes. But you can see that when I stand to the right, the node 3 is actually blocking node 2, so we have to render node 3, all right? And on the third layer, well, you can see that in the output of this example, we have 137, and the 7 is basically the most right element at that level. All right. It is possible though that if let's say that the child 3, well, the child of 1, the right child of 1, 3 has no child. So in this world, in this 2D world, if I stand to the right and 3 has no child, the rightmost element I will see on the third level will actually be the 5, right? So we can just go for every single node and append to the output node that right, okay? I actually tested out the first time I tried to solve this problem. Um, but actually there is this these edge cases where the right element is actually not present. So it has to be the most right element within that level. So the data structure that we are going to use for that is actually a queue. And for each level, we are going to add in the queue the value starting from the left. And basically, we are going to just append to the output list the rightmost value that we have in our queue. So for example, let's say that we have this tree, and let me just do some cleanup. So in this tree, we can see that initially, if we set up our queue, we are gonna add on the first level, we are gonna add our 17. All right, so let's say this horizontal bar here represents a queue where this is the beginning, this is the end. So we are gonna add our 17, and then it is the only value. So we are gonna just add our 17 to our output array. And after this, we are gonna pop that 17 and add its two child starting from the left, right? Quite important this. So we are gonna add our 5 and we are gonna add our 35. Okay. And after this, we are gonna pop every values, and we wanna find a way to actually get that last value. So what we are gonna do to get that 35, which is the rightmost value, we are just gonna say initially that we wanna do a for loop within the range of the length of that current queue length, right? Because right now the length is 2, so we want to go for 1 and 2. All right, so this is how we are gonna do. And after this, we might just gonna have a variable. For example, we can call this like right value, and every time we are just gonna update that right value to the node that we are popping. So initially, our right value is gonna be equal to none because it is possible that we have actually reached the end of the tree, but in this case, we are at the second layer, so we are not at the end of the tree. So when we first pop from the left the value 5, well, right value is going to be 5, but then after this, we are going to pop again our 35, and our right value is going to be now set to 35, and then we are going to break that loop. So the right value is going to be set to the rightmost value. So this is how we are going to resolve that last value. And same thing for the third level. We are going to add, basically, once we pop the 5, we are going to add the two child starting from the left. So we're going to add here 2 and 16. And same thing for 35, we're going to add its two child, so 29 and 38. And once again, we are gonna set another right value, and we are gonna add it, and we're gonna set that right value to the value that we just popped, so that the last value we pop is gonna be basically setting the right value at this level. So let's go ahead and code this. We know the basics now. This is actually breadth first search. Okay, so using a layered approach. So um, all right, first we want to create our output array, and after this we are going to be willing to create a DQ. Whoop! I opened the console. So we want to create a DQ where we initially have the root in it. Okay, so this is how we start a problem, and then we want a while loop. We want to use a while loop until there is a value in the DQ, because every time that we pop out a value, we add its two childs. So if we popped out every single values in the DQ and we add no childs, meaning that we actually reached the last level of that binary tree, it means that we are done. So we can return at this point. So this is why we are gonna do a while loop while there is a queue. Okay, and after this we are gonna set the right value. Okay, remember this. So right value is gonna be initially equal to none. All right, and this is where we are going to say for I in basically the range of the length of Q. Whoops, so we take into account all the values that are currently in the queue, and all the values that are currently in the queue represents all the values at that particular level. So what we are going to do is that we are going to set that value that we pop from the left to the variable node. Okay, and now we want to check basically if node exists, because node might actually be there might be no child, right? Because when we pop from the left, we add its two childs, and the two childs might be none. So on the next round, it is possible that the value we are popping is actually none. So we have to ensure that it is not none. And if this is the case, we are gonna set the right value to be equal to that node. Okay, so every time we go on in the for loop, we are gonna reset that value to the latest value that we just popped. And after this, we are gonna add this to child. And now it is important that we add the left child before the right child, because we have to ensure that the right child is actually to the most right. Like it cannot be popped before a left value, otherwise it's gonna break our logic. So we are gonna append first node that left, and then we're gonna append node that's right. Okay, all right, and after this it is possible that all the values in the DQ at this moment were none. So if this is the case where all the values in the queue are none, it means that the right value is still none. So we don't want to necessarily add a none to the output value. So we are just gonna check basically if there is a right value. Okay, so this is gonna save us a lot of trouble, and this is where we are basically gonna append that right value, that val, right? We're gonna add this to the output, and that's pretty much it. After the while loop, we can return the output, and if I did everything right, we should get the correct answer. So let's see this, and there you go. All right, so I hope you learned from this video, and I hope to see you in the next one.